I'm going to solve and show you how to do the 2013 AP Environmental Science free response question. Take a minute to pause the video and make sure that you read the whole prompt carefully, underline, highlight, whatever you need to do. This is a long math with a lot of reading in this particular FRQ this year. They're not always this way. When you're done, you can unpause and we'll get started. All right, so 2B. Now, A is missing because A was not math on this particular year, so I only put on here the problems that were math. All right, so assume the fuel efficiency of the ICE vehicle, which is the normal cars that you and I are used to driving, unless you have a battery one, which you're super lucky if you do. So an ICE vehicle, internal combustion engine, is 25 miles per gallon and gas costs $3.75 per gallon. Calculate the cost of gasoline per mile. Okay, so we know that gas costs $3.75 and this particular car gets 25 miles per gallon. So how am I going to set it up? Am I going to set it up like this? Or am I going to set it up like this? Because both of the givens let us have that option. Anytime you have per, you can write the number at the top or the bottom. So which one should we use? Well, let's look at what our question is asking. So the question is asking cost per mile. So my answer needs to come out like this: money per mile. So which one of these gives me money per mile? It's the second one. So I need to use this one because the money is here at the top and the miles are here at the bottom. And so that's the correct answer that I need to use. Also, let's say you don't remember that and you do it this way. The answer comes out kind of strange and it doesn't quite make sense. The cost is too high per mile. So let's go ahead and solve this now. So we want 375 divided by 25. So 25 goes into $3.75. All right, so our gallons cancel. We're going to end up with dollars. So my decimal's up here. So 25 goes in once. I'm going to subtract. Bring my 5 down here. And it goes in evenly 5 times. So my answer is 0.15 per mile. So dollars per mile. So 15 cents per mile. If you did the problem the other way, you'd end up with a cost of a lot more per mile, which is not a logical answer. Going on to C. CI, calculate the cost of the electricity to fully charge the battery. Assume the battery is not charged to begin with. If you haven't read the prompt before C, make sure that you pause and that you read it, and then unpause. All right, so we need the following givens. So we need 4 kilowatts. And it says it charges 7 hours. So remember, our kilowatts are kind of strange. You take kilowatts and you smush it together with hours. And you get 28 kilowatt hours. It's not kilowatts per hours, it's actually kilowatt hours all smushed together. And we learned that a little earlier, and we will learn it some more this year. Then it tells us that it costs to make that electricity 11 cents per kilowatt hour. That's actually pretty cheap electricity. In California, our electricity is more like 18 to 30 cents per kilowatt hour. And so the money is per kilowatt hour. So now I can just go ahead and multiply 28 times 0.11. And I'm going to do this over here. And this is dollars, so it comes out as dollars. And in my problem, I had 2 decimal places, so I got to make sure I have 2 decimal places in my answer. And so my answer is $3.08. Don't forget the dollar sign. And this is to charge. So it only costs $3 to charge the car to go 100 miles. Pretty good deal there. CII. Calculate the cost of electricity per mile to drive the battery electric vehicle. And so it tells us we're going to go 100 miles on a full charge. So we're just going to take the 308 and we're going to divide it by 100 because it's going to travel for 100 miles. So I can go ahead and do my math like this. If you can do that part in your head where you just move the decimal point over, that's fine. You can do that. So your answer is 0.0308, and you're going to round to the nearest whole cent. And the cost is 0.03 cents per mile. Don't forget your units. Units in your work, units in your answer. And dollar signs are units also. Now what if you left it like this, 0.0308? That was fine. They were not going to mark you off for leaving it as 0.0308 per mile. That's fine. All right, going on to D. D is the easiest one of all. So another year, and this happens quite frequently, where on the FRQ, number 2 for that year, the last problem is the easiest one to solve. So don't give up. If you can't solve the earlier ones, go down to the next one. Take a minute and read the prompt to review what you need to do, and then unpause the video. All right, for this one, it says that the regular internal combustion engine car releases this much CO2, and then to transport and extract the gasoline, it produces this much CO2, and so we're just going to add these together. So this is an addition problem, and then it tells us that making the battery and charging the battery burns coal primarily in the US, so coal emits CO2, and so we're going to subtract this amount from the CO2 cost of charging the battery. And that's something to keep in mind, is that an electric vehicle is not no emissions. If you are in a state that burns coal, you are going to end up still polluting, but not as much. It is better. In California, we burn natural gas, which is a cleaner fuel, so we end up being a good thing for electric cars. All right, so our answer here is 26.9 pounds of CO2. So this was addition and subtraction, so not a hard problem to solve, and that's it for this year.